say 2.5 one more time. Yes, I do have one transformation that we skipped, if you remember. We left it off. I will not test you on this transformation, which is a horizontal stretching or shrinking. I will not test you on this one. Why? Because this is really useful for trigonometric functions, but we don't have trig in this course. But I don't want to skip it in the sense that not to show you one example, just one example to see what it means. Why did I leave it at the end? It's because all the other ones, I would say, are straightforward. This one is not. And you'll see in a minute why. Now, if you do see my MATLAB problems, bring at least one to class for everyone so I can show you an example other than what I'm showing you right now. So let's take a look at f of x equals x cubed. Have we seen this function before? Now, again, I just wanted to say one more thing. I repeat myself so much. I'm in the hope that you will remember what I say. So I apologize for doing that. But if you pay attention and if you take notes and you go back and redo, I doubt that you're not going to do very well in this class. I doubt. So good. So have we seen this function before? Yes. When? Let me refresh your memory. Let me show you how it looks, because we're going to discuss it again in chapter 3. It looks like this. And I know you've seen it because we talked about it a lot. When and when. When and what about, I meant to say. When we discussed. Okay, here is a hint. Odd and even functions. Yes, we established the relationship of the odd functions based on this one. That's what we graphed. Okay. Now let's suppose I would like to graph f1. I'm just going to call it differently because it's a different function of 2x. And another one, let's say f2 of 1/2 x. Like with any transformation, what is the first thought? The first thought is, what am I changing? Am I changing x? And if I say yes, then there is a transformation on, correct? If I say I'm changing y, then it must be something going on vertically. Excellent. So what am I changing? Indeed, I'm changing x from x to twice x, and later on, for a different example, from x to 1/2 x. So what type of transformation, where will it be, since we already mentioned that? So you said we are changing x. Perfect. So then something happens on the horizontal, right? Okay, perfect. So now I would like to determine this f1 by plugging it in. Since I don't have enough room, I'm going to go here. So f1 of 2x, based on this one, I'll have 2x to the third power. And how do I raise a product to a third power, to a power? I raise 2 to the third power and I get, very good. And I raise x to the third power, good. Now forget about where this is coming from for a moment. And I'm asking you, how do I graph x cubed? How do I graph 8x cubed? I have two options. This is one option, vertical stretching. And here's the second option, vertical shrinking. Because I'm changing y. It's outside, right? So this is x cubed. Is this 8x cubed or is this 8x cubed? Number 1 or number 2? So when you say number 2, it means that it's a vertical shrinking, and you multiply by a number less than 1. Are we multiplying by a number less than 1?
No.
No. So then it must be this, right? So this is x cubed. 8x cubed must be this. But now we'll forget about the vertical. Look at the horizontal. What happens horizontally when I do from x cubed to 8x cubed? What happens horizontally? Yeah, it's completely the opposite. When I change x into twice x, it's a horizontal shrinking of the graph. And when I change it into 1/2, it's a horizontal stretching of the graph. It's exactly the opposite. That's why I didn't want to put it together with the other ones. So this one, although I'm changing x into twice x, this is a horizontal shrinking by a factor of 1/2. So therefore, what will this one be? When I change x into 1/2 x. Yes, exactly the opposite of what you would expect. So this is a horizontal stretching by a factor of 2. We don't have to do anything with this. If you do come across an example, please bring it to class so we can talk about it. There are examples in the book. If you want, we can look at one. It's up to you. I'll tell you where they are and you can choose, or we move on. It's up to you. I'm sorry, no. No, I would not put this one on the test. We have enough. Okay then. But if you do come across one, if you remember I said that my math lab course is not created by me. So if you do come across one, please bring it to class. Even if you solve it correctly, please bring it to class for everyone to see so I can show it. Okay? Good. So 2.6. I like to call this algebra of functions. Algebra of functions and function composition. Algebra of functions and function composition. Well, algebra deals with addition, subtraction, multiplication, and division, but this time of functions. So given two functions, given f of x and g of x, please give me two functions, f of x and g of x. Anything? Very good. Minus 5, and let's say x minus 2. We can create 4 different functions with these. Well, actually 5, but when you talk about algebra, 4. We can create this function. Careful how we read it. F plus g of x. What do you think this equals to? And do not replace anything just yet. Just give me the definition. What do you think it is? It's what it says it is, which means x plus g of x. Now I can replace them as 2x squared minus 5 plus x minus 2. And remember everything in descending order. How will I present this in descending order? Very good. What does this function represent? The sum of these two. It will still be correct, yes. Now, what do you think this function represents? Exactly. The difference? I copy 2x squared minus 5 minus, please put in parentheses x minus 2, or remember to distribute. It's up to you. But you have to distribute. And this will be 2x squared minus 5 minus x, but plus 2, which changes into 2x squared minus x and minus 3. This is a new function that was determined by subtracting the given functions. Of course, the next one will be, what do you think? What do you think I am going to list next? Of course, fg of x, which by definition will be f of x times g of x. All I have to do is copy them, and they are 2x squared minus 5 side by side because I'm multiplying them. And I do have to use FOIL here because there are two binomials. It doesn't matter whether you start with x and distribute, or you started with 2x squared and distribute, it does not matter. So this is 2x cubed minus 5x minus 4x squared and plus 10. So I distributed x, 2x cubed minus 5x, and I distributed negative 2. However, I have to present it in descending order, which will be 2x cubed minus 4x squared minus 5x plus 10. And that is a new function that was created by multiplying the given functions. Okay, what is the last one? What do you think? Yes, of course. So given the functions that we had, f and g, now we can create a new function by dividing them. So f divided by g of x is f of x divided by g of x. I copy 2x squared minus 5 over x minus 2. I put a comma, and this time I must write if. I didn't have to write this before with the other three, but I have to write if right now. Why? Well, what does it mean? Excellent. Can anyone explain why the bottom cannot be 0 other than Ella? Correct. Which means x cannot equal?
X2.
Very good. Very good. Excellent. So, coming back, this function, and this function, the sum, difference, and product. Can anyone give us the domain of the sum, the difference, and the product? If I ask you to replace x by 5, can you give me an answer? By 0? By 1500? By negative 3?
Yeah.
By 10? So what is the domain? Now I would like to find the domain of the ratio. But they're all polynomial functions. The domain is always all real numbers. You can plug in anything and get an answer. All polynomials. Cubic, quadratic, quadratic. In all these functions, there is no square root that I could worry about. There is no ratio that I could worry about. I can plug in anything I want. Since I will always get an answer, domain all real numbers. But now what is the domain of the ratio? X cannot be 2, right? So then how do I write the domain for the ratio? Exactly, but we write it like this. Exactly. We write anything but 2, correct? From negative infinity to 2, union 2 to infinity. Do we agree with this? Everyone? Yes, in interval notation, that's how we write it. Good. So every time I want to add, subtract, multiply, or divide functions, there is a potential problem. Well, let's see what is the potential problem here. So let's graph two functions. Here's 1. Let's say between -2 and 10. And I have another, let's say between 2 and 14. So this is G, and the green one is F. So now I'm going to ask you, find F plus G of 11. You will say, piece of cake. This is F of 11 plus
G of 11.
Of course. And you will say, for G of 11, 11 is here. It crosses the graph in this point. And let's say you read 1. But then you have to find F of 11. And what would you say? Say it again. Correct. Undefined. F of 11 doesn't exist. Why? Can anyone give us the domain of F? Very good. -2 with a parenthesis, 10 with a bracket. Awesome. Can anyone give us the domain of G? Domain of G. Very good. 2 to 14. So now, obviously, I cannot ask you to determine F plus G of 11. You will say, sorry, I can't give it to you. It doesn't exist. I cannot add 1 to something that doesn't exist and give you an answer. So looking at these graphs, what would you advise me? You will say, Monica, if you want me to evaluate your functions, sum, difference, product, or ratio for anything, you'd better select X where? Where, exactly, the whole thing. Where can I select X from? Between? Exactly, where they both exist at the same time. So if I don't select between -2 and 10, your answer will always be, sorry, I can't give it to you. This is what it's called common domain. In this case, 2, 10. So if I want you to determine F over G at 3, will you be able to determine it? Of course. At 5? At 2.3? What about 1.9? No, because one or the other doesn't exist. So what do we conclude? Yes, I can create new functions given 2. I can create a sum, difference, product, or ratio. But there is one condition without which I can't create them. They have to have at least even one number. If they don't have an interval, at least one number. Otherwise, the functions mean nothing because you cannot plug in anything in them. So, sum, difference, product, ratio can be created of 2 functions, can be created as long as F and G have common domain, a common domain. Otherwise, nobody cares of the functions that don't exist for any x value. So sum, difference, product, and ratio can be created as long as F and G have a common domain. If they don't have a common domain, there is nothing we can do about it. Okay. So let's look at one more example from your book.
And the domain is from the smallest point to the...
From the leftmost point to the rightmost point on the x-axis. So for example here, for F, is between the leftmost point, which is -2, till the rightmost point, which is 10. For G is between the leftmost point, which is 2, and the rightmost point, which is 14.
I used to, wait.
Say it again.
So the F of 11 is undefined, but the G of 11 is 1.
Right. So I'm telling you, please add 1 to something that doesn't exist. What number will you come up with? So they both have to exist for this to exist. But one exists and the other one doesn't. See? This line at 11 does not cross the green graph.
Okay, but
The domain of the green graph is between -2 and 10. At 11, the function does not exist. And we say it's undefined.
Okay.
Better? Yes?
Yep.
Good. Other questions? Okay, so let's look at an example. Let's say 34. I wanted you to see a problem from your book. We have f of x equals x minus 6, and g of x equals 5x squared. First, we have to find the domain of f and the domain of g. Can anyone tell us what is the domain of f and what is the domain of g? What can we say? Right, both of them. Good. So then what is the common domain? Of course, everything. And this domain will always, forever, and for any function, be the domain of the sum, the domain of the difference, and the domain of the product. Always. Always. The common domain will always be the domain of the sum product, the sum, difference, and product. But what about the ratio? I don't know. Because in the ratio, there is an if. So I have to create the ratio, and then I'll decide what the domain could be or should be. Okay, so now we're asked to find, the question is asking us to find the sum, difference, product, and f over g, because I can have g over f, or I can have g minus f. Determine the domain for each function. So I don't have to determine the domain for these three functions because I already wrote it. It's always, always. Oops.
Would this be the common domain?
Common domain, yes. Yes. Sorry about that. Common domain. Good. So let's find the sum. Let's write f of x plus g of x. F of x is x minus 6 plus 5x squared. All you have to do is just rearrange it. There's nothing. We don't need to do anything. The next step will be what? What is the next function? Very good. F minus g of x. Please write the definition, which is f of x minus g of x. Please write x minus 6, but minus 5x squared. Yes, we have to rearrange it. Of course, the next one is fg, which is f of x times g of x. And f of x is x minus 6, and multiplied by 5x squared. Can anyone give us the product? We're multiplying a binomial by a monomial. Yeah, it's not FOIL because this is just one term. It's just a distributive law. So 5 cubed minus 30x squared. Is it clear why all these have domain all real numbers? Yes, we knew that from the very beginning. So finally we have f divided by g, which is f of x divided by g of x, which is x minus 6 over 5x squared. However, I have to put a comma and what? Exactly. If what? What could be the problem? If, awesome, x cannot be 0. So now, is it clear why the domain of this function cannot be the common domain? But from the common domain, I have to exclude this one. So what will be the domain of the ratio, please? Excellent. Great job. There is a fourth way. I'm sorry, there is a fifth way, forgive me. There is a fifth way of determining new functions given, bless you, given two functions. The fifth way of creating new functions. So we know 4 ways: adding, subtracting, multiplying, and dividing. Let's look at the fifth way. I didn't want to name it just yet. That's why I wrote the fifth way. So let's take a look. Let me caution you that the fifth way has nothing to do with adding, subtracting, multiplying, and dividing. Nothing. Ready? Okay, so let's say I have x here. And let's say I choose to apply a function g to it. What do I get? Excellent. Thank you. Awesome. If this is 5, this will be? Excellent. Awesome. Great job. Perfect. Now this is a number. Because if I apply g to 5, I get g of 5, which is whatever number. To this number, I decide to apply another function. This time, a new function called f. What do I get now when I apply f to this number? Excellent. Well done. This is called function composition. Notice that we inserted a function inside another function. So this is not adding, subtracting, multiplying, or dividing functions, but something, a totally new procedure, totally different. Perfect. So now, here is the notation. F comp g of x. Which is that? F of g of x. So you can say, wait a minute. You started with g and f was applied later, but you put f in front. Right. Here's why. Because first I apply g to x. This is the so-called inner function. Then I apply f to this number, which makes this one the outer function. Outer, inner. Yes? That's the notation. So it's not addition, it's not subtraction, it's not multiplication, it's not division. Is this empty circle, and this is called f comp g. Another way of reading it is the composite of f and g, whichever you prefer. You either say f comp g in short, or you say the composite of f and g. Now, what if I want the composite of g and f? Megan, how do I write the composite of g and f? Can you put that cell phone away? Please. Okay. G comp f of x is the composite of G and f. And can anyone give us a definition? How we calculate it?
G
Of f of x. Not times, G of f of x. Perfect. Excellent. Well done, both of you. Great job. So can anyone give us here two functions? What is the inner and what is the outer? Which one is the function that we apply first to x? Of course. Which one is the function that we apply after we get a number here? Which function do I apply to this number? Excellent. So we don't know function composition yet, but I'm going to give you two functions because this is very important. Let's say the absolute value of x squared minus 3x plus 9. I want you to decompose this function into an inner, and there is more than one correct answer here, and an outer. How do I, let's analyze this for a moment before you choose, before you tell me which one is what. When I'm asked to evaluate this function for 0, which portion of the function will I evaluate first? The x squared minus 3x plus 9, correct? That's one answer. This is not the only correct answer, right? So first I have to calculate what's inside. Let's say I get 15, and then I apply what function to 15? The absolute value, correct? So if the inner function, you selected the inner function to be x squared minus 3x plus 9, and once I get a number here, which function will be the outer?
The same thing. Well, plus, right? That's absolute.
That's why I covered it. It's gone. That is what I covered is the inner function. Done. Exactly. Of that number. Exactly.
Wait, what? The absolute value of what number?
So let's go back here. So if this is 5, I get g of 5, which is 15, and I apply the new function to 15. This function can be anything, right? But I apply this one to 15. So coming back here, once I decided that this is the inner function, once I get this value to be 15, then I apply which function to 15?
So
the absolute value.
Okay, so again, if you're going to solve that and whatever number
I'm evaluating it. I'm not solving. It's not an equation. So if I want to evaluate this function for 0, I will evaluate this portion first. I get a number, 9, and then the absolute value is applied to 9, which is the absolute value of 9. Correct. Let's do another. So let's say we have g of x, 1 over x squared minus 3. I would like you to decompose this function into inner and outer. Just think in terms of you are evaluating this function for something. Which portion will you evaluate first? Yes?
X squared minus 3.
Excellent. Once I get a number, which function I apply to this number? That's why I covered it so you don't get confused. X squared minus 3 is taken. What function will you apply to this number? What function? 1 over 1 over x. Indeed. Indeed. Very good. Any questions?
Why is the 1 over x?
So once I evaluate this function for 1, 1 squared minus 3 will be negative 2. Which function I apply to negative 2? 1 over negative 2. 1 over x. Is that better?
I don't know. Not really. But I think I understand.
So if you evaluate this function for 0, first you have to evaluate this function, which is the inner function. You have no choice. You have to start from here.
So it'd be 0
Minus 3.
And that's when you
It was negative 3. What do you do with negative 3? You plug in a function that is 1 over x. You plug in negative 3 here. 1 over negative 3. 1 over negative 3.
Because it's 2.
Because it's 1 over something.
Okay.
We need another? Okay, very good. Let's choose from your book this time. They are on page 311, 75 through 82. 75 through 82 on 311. Which one? Excellent. That's exactly what I was going to ask. H of x equals the square root of 5x squared plus 3. So we need to decompose this into 2 pieces. There is more than one correct answer. I can come up with a correct answer. You can come up with another correct answer. So we want the inner and we want the outer. Indeed. There is no escape. And what will be the outer once you get a number? I apply the square root of x to that number. Indeed. Any questions? Any questions?
It's the square root of x because it's if you solve it. Well, if you evaluate it.
Correct.
And whatever number you get,
Then I have to apply the square root of x to it. Better?
For these problems, we don't solve, we just evaluate them and find the inner.
No, we are just asked to decompose. This particular exercise is for the next class, basically. Less for this one, but more for the next one. If you need to take a brief calculus, math 230.
But this will be on the test.
Yes.
Okay.
Yes. Okay, so for now we decomposed, but I haven't shown you how to compose them. Okay, so let's choose 2 functions. Choose any 2 functions you want from 51 through 66. Same page, 310, I'm sorry. We're given 2 functions and we will be asked to find the function composition. 60 is a good, which one?
60.
I said 59.
Okay.
67.
Good, so you can do 59 and check the answer. So 60, we are given f of x, which is 5x minus 2. And we are given g of x, which is negative x squared plus 4x minus 1. And like with the sum, difference, product, and ratio, what was the potential problem with those? What was the potential problem with those?
You may not have the same
The common domain, yes. Here, there is a potential problem, but not the common domain. They don't have to have a common domain. I will show you what the potential problem could be in a minute. But I will not test you on that. Why? That's a topic for calculus and pre-calculus, especially for pre-calculus. But I will show you one. Okay, so then we're asked a few things in number 60. Find f cum g. G cum f cum g of 2, and g cum f of 2. So they want f cum g of x. They want g cum f of x. They want f cum g of 2. And they want g cum f of 2. Now you understand this symbol, the circle, the empty circle, signifies function composition. To differentiate it from the sum, difference, product, and ratio, of course, right? So that's the notation, that open circle between f and g. Okay, can anyone give us the definition of f comp g? F comp g of x. I have to write the definition. By definition, this means, like we wrote with the sum. When we had f plus g, we wrote f of x plus g of x. But how do I write this? F comp g of x. F of, excellent. Remember, I have to start from the inside. Don't erase anything. I'm just making a point. This is my inside. This is my inner function. That's where I start. Can anyone dictate what is g of x? I have to replace g of x first. G of x.
Negative.
Yeah. Yes, negative x squared plus, thank you. Sorry, my apologies. But now I have to look at what f is telling me. F says f of whatever is 5 times whatever minus 2. But this is my whatever now. Exactly. We are plugging a function inside another function. Correct. So then I have 5 quantity negative x squared plus 4x minus 1 and then minus 2. Is this understood? This is what we've been doing for a long time, right? So when we look at a function, f of whatever is 5 times whatever minus 2. So then f of whatever is 5 times whatever minus 2. Agreed, everyone? Yes? Are you with me? Okay, so then I distribute. Negative 5x squared plus 20x minus 5 and minus 2 is minus 7. So this is a new function, not obtained by adding, subtracting, multiplying, and dividing, but obtained by function composition. Plugging in f, a function, which is g of x. Since I have the function, so this is done. Since I have the function, I want to determine this right away. Good. So how much is f comma g of 2? How do I get it? Right here. This is f comma g. So if x is 2, all I have to do is plug in 2. So negative 5 times 4 plus 20 times 2 and minus 7. This is negative 20 and this is 40. So it's 20 minus 7, 13. Any questions on this? To square first, so I had 4. Negative 5 times 4 is 20, negative 20, and this is 40. 40 minus 20 is 20. 20 minus 7, 13. Can anyone dictate? If you have questions, stop me, please. Please stop me if you have questions. Anyone? Now, can anyone dictate the other function, g comma f? I need the definition first of f of x. Good. Which is g. Remember, I have to start with the inner function. I have to replace the inner function. What is the inner function? But now I have to be very careful and I have to go back to g. Look what g is saying to us. G says g of whatever you want, negative that whatever squared plus 4 times that whatever minus 1. So please dictate.
So can you use 13?
We're on a different function. We're on function g comma f.
So then it's like 5 times 5.
So first I have negative outside. This piece now is 5x minus 2, and I have to put it in parentheses. By the way, when I square a binomial, how many terms will I write? And please do not say 2. First day of classes. Very good. And then plus 4. Now this piece is 5x minus 2, and then minus 1. Do you see this in the pattern? Do we all see this in the pattern? Yes? So the minus is outside, 5x minus 2 is inside, plus 4 is outside, and 5x minus 2 is in parentheses minus 1. Is this clear?
I have just one quick question.
Please, please.
G 5x minus 2. That is, so g of f
Yes?
times x equals g. Can you explain why it's 5x minus 2? F of x
I replace f of x by 5x minus 2. Better?
Yeah, it's just 4 parentheses because it's, like you said, it's inside of a function, another function. Right?
No, because I have to square. The function tells me to square.
No, I'm talking about the. Honestly, did I write it wrong? The g of x of x of f of x.
Correct. So
Is
the
in-
definition of g comp f is g of f of x. I have to replace the inner function by what it equals to. So I
Right.
replace the inner function by 5x minus 2. And now I have to replace the x in g by 5x minus 2. I copy negative 1. I copy 5x minus 2 squared. I copy positive 4, multiply by 5x minus 2, and I copy negative 1.
I was just talking about the parentheses.
Oh, yeah, yeah. Which one?
So the g of f of x.
Yes.
4 parentheses because, like you said, it's a function inside of it.
Correct. Correct. Yes. No, this is the definition. So g comp f of x is g of f of x. This is carved in stone. This is carved in stone. This means that. Better?
Okay.
Good. So then I have negative outside. Can anyone give us 3 terms for this? With parentheses, because later on we have to distribute. Yes, 4 times 5. Very good. 2 times 2 times 5. Very good. X plus, excellent, plus 20x minus 8 minus, not 2 but 1, sorry. Is everyone with me on this? Yes? First term squared minus 2 times the first times the second plus the second term squared. A binomial squared, first day of classes, is a trinomial. So a minus b, everything squared, please, please. That's why I'm begging you to redo these problems. A squared minus 2ab plus b squared. That's what I said. When you square binomial, please don't say that we get a binomial. Everyone with me? So now I distribute negative 1. So this is negative 25x squared plus 20x and minus 4. And then plus 20 and minus 9. One more time, negative 25x squared plus 20x, and this is plus 7. What does this function represent? It represents g comp f. So it's this piece. But now they also want g comp f of 2, which becomes a piece of cake. How much is g comp f of 2? Plug in 2. Negative 25 times 4 plus 20 times 2 and plus 7. So this is negative 100 plus 40 and plus 7. So negative 60, negative 53. And this is the function g comp f evaluated when x is 2. Yes. Any questions? Please ask anything. Is this okay?
I don't know if I miscalculated. So the second,
Maybe I did.
the second 20 after the negative 4, that's an x. Yeah, would it be 20x or is, I don't know where you got that. Okay, that's why I was getting confused. Yeah, after that I was like, oh man, I messed up. Yeah, okay, that makes sense.
I'm sorry. So negative 25x squared and plus 40x and minus 13, sorry. And then this changes now. So this is 40 times 2 and minus 13. I'm sorry. So this is still negative 100, and this time is 80. So negative 20, so negative 13. Sorry, I didn't copy the x. No excuse, no excuse, no excuse. So now I want to check everything again. Indeed, and minus 9. So this is 40, that's correct. Minus 13, it's correct. 2, yes, negative 100. Minus 80, that's negative 20. Ah, yeah. That's why once I make an error, I go back and check everything. It's safer that way. Thank you. Okay, so, and this is minus 13. Sorry. So this is minus 20, and minus 13 makes it minus 33. No, I wasn't trying to see whether you were asleep or not. Sorry, my apologies. Any questions on this? Any questions? Okay, let's talk about the potential problem. I will not test you on that, but I would like you to see it. Potential problem. With function composition.
But we're not going to see this.
No, I'm not going to ask you this one, no. So let's go back to the bubbles. We already established that if this is x and we apply g to it, what do we get? G of x, very good. And then we continue applying f to it, and we get f of g of x. Perfect. So now, please tell me, what does this set represent for g? It's a set of values of x for g. So how do we call it? It has a special, exactly, has a special name. We have to remember that. Perfect, excellent. Now, can anyone give us what does this set represent for g? Exactly, thank you very much. Good. So now let's look at f. What does this set represent for f? Excellent. Domain for f, and I have to be very specific here, range for g. So here is the potential problem. Let's say I apply g to a number and I get 15, but I cannot apply f to 15. F is not defined at 15. I could never land here. So the problem here is this, and I will not ask you to find the domain of the function composition. I will ask you to find the common domain and the domain of the sum difference product ratio, but not the domain of the function composition. So what could go wrong here? The range of g does not work well with the domain of f. I can bring from g a value that f cannot be applied to. So there is no discussion of common domain. The range of g and the domain of f have to work well together. Otherwise, I have to make adjustments here. But this concept is a little bit more, I would say, sophisticated, and I don't think it should be the part of this course. However, if you find any question like this on the domain of the function composition in my math lab, please bring it to class so I can present it to everyone. I will not test you on finding the function composition, the domain of the function composition. I will not. Any questions? Okay, 2.7, inverse functions. When we started chapter 2, I refreshed your memory on function definition. And we had 3 different sets of bubbles. One of them was not a function. What about this? 3 values, 3 values. Is this a function?
Yes.
Perfect. Here's another. Is this a function? The answer is yes, because each x value corresponds to one y value. Each x value corresponds to one y value. Each x value corresponds to one y value. But these two are very different. One of them has a very important property that the other one does not. So here's the property before we talk about it. Let's suppose I go from set A to set B in this case. And now I want to go back. I want to create a function that is defined here and takes values here. Can I do that? If I go backwards, do I create a function? Yes or no?
No.
The answer is yes, because for each x value, I have only one y value. For each x value, I have only one y value. For each x value, I have only one y value. So if I decide to go back, I can create a new function. That is a function. Now, what about this one?
Oh.
If I want to go back with this one, can I create a function? No. So this has a very important property. To each y, there is also only one x. Not just to each x, only one y, but also to each y, there is only one x. That property is called 1-to-1. To each y, only one x. 1-to-1. Is this function 1-to-1? No, not 1-to-1. So now you are going to help me write a statement. And here's the statement. Only functions have inverse. Does this one have an inverse? Yes, but it's not a function. It has an inverse. It will be a relation, but it's not a function because it doesn't have the property. So only blah, blah, blah functions have inverse functions. Which functions have inverse functions always? Only? Exactly. Only 1-to-1 functions have inverse functions. If a function is not 1-to-1, it will not have an inverse that is a function. It will have an inverse, but not a function. Any questions on this so far? Okay, so 2 graphs. Here's one, and here's the other. We've seen both graphs throughout the entire 5 weeks, 6 weeks. Can anyone tell us what function is this? And we graph them many times. What function is this? Quadratic. Very good. Quadratic. What function is this? Excellent. If we're talking about for each y there is only one x, first of all, are they both functions? That's a silly question. We graph them so many times, we know they're functions. By the vertical line test, they are functions. But now I want to identify whether they are 1-to-1 or not. For each y value, how many x values will I read? For each y value, how many x values will I read? By the horizontal line test, this is or is not 1-to-1. F of x, which is this, is or is not 1-to-1. Is 1-to-1 by the horizontal line test. By the vertical line test, I say it's a function. But by the horizontal line test, I say it's 1-to-1. What would you say about the quadratic function? Not 1-to-1. I do have ways of creating a function from this one that is 1-to-1. I say it's quadratic, but I only want the domain 0 to infinity. And I created a 1-to-1 function. if I wanted to. Okay, we can play with that. So now, here's my next question. I would like us to create two functions that are inverses of each other. What will inverse functions do? First of all, they will annul the effect of the function on x. So let's say Charisse here has an unknown number of dollars in her pocket, x, or pocketbook or purse, x dollars. I'm giving her $5, so now she has x plus 5. 5 minutes later, I come back and I say, I want my 5 back. What happened to her x in her wallet? Nothing. I gave her 5 and I take it back. I took it back. So what happened to her pocket? The amount of nothing. So what functions did I create? Can anyone give us two functions, one that is f of x and the other one that is g of x, that in such a way that nothing happened to x? I can do the reverse. I'm going to say, Charisse, please give me $5, and 10 minutes later, I'll give it back to her. So can anyone give us two functions that are inverses of each other? Yes?
X plus 5, x minus 5.
Exactly. What will be the function composition of f comp g and the function composition of g comp f of x? And think in terms of, I gave your colleague $5 and I took it back. Or I asked her to give me 5 and then I gave it back to her. What should the answer be? If these indeed are two inverse functions. What was she left with in her pocket? This is the property of inverse functions. Property of inverse functions. F comp g of x and g comp f of x must equal, and you tell me what, if f and g are inverses of each other. So one more time, f comp g and g comp f must be if they are inverses of each other. I gave her 5 and I took it back. I took 5 from her and I gave it back.
Must be what?
Must equal
Must equal.
to what? I'm waiting for you to tell me what to write. I did not write it yet. And they have to equal each other, and they have to equal what? Right? X. So this is the property of inverse functions. Let's look at two functions.